Hey, Food Science, welcome back. So in the last video, we talked about why it's important to know about acids and bases and ions and pH and all that fun stuff. But this video is intended to show you that water is the basis of everything we are going to be talking about in this section of our class. Water ionization helps us understand how acids, bases, and salts come about. Small amounts of molecules continually separate into ions and then recombine into different structures. And we'll see a GIF in the next slide that'll show that pretty clearly for you. Ionization, whenever I say that word moving forward, I'm referring to the process of forming and creating ions. And this reaction can move in either direction. We can have cations or anions, okay? A cation is positively charged ion, and an anion is a negatively charged. Just like in a storybook, we have an antagonist, that is someone who is going against, or it's the negative. Okay, so anions are negative, cations are positive. During the ionization of water, a hydrogen atom breaks away and becomes a positively charged hydrogen ion that bonds with a water molecule, forming a hydronium ion. So I'm going to pause there. Take a look at the GIF to the right. We initially see two water molecules, right? Hydrogen is gray or silver, and oxygen is red. You can see clearly that we have two water molecules initially. Because of the attraction that is occurring and the chemical changes, we are having ionization occur. On the left side, we see our hydronium ion being formed. There are 3 hydrogen and 1 oxygen. This forms a positively charged hydronium ion. Okay, we're going to move on. The hydrogen atom remaining in the OH group shares its electron with the oxygen atom, forming a negatively charged hydroxide ion, or OH negative. We see that on the right-hand side at the end of the GIF. There's 1 hydrogen and 1 oxygen atom together, and that forms a hydroxide ion, or OH negative. Our hydronium and hydroxide ions are utilized in acids and bases to help us classify if something is acidic or basic or neutral. Hydrogen, hydronium, and hydroxide acids are used to define acids and bases. Okay. Acids produce hydrogen and hydronium ions in water-based solutions and have a positive charge, whereas bases produce hydroxide ions in water-based solutions and have a negative charge. Okay? So hydronium ions, again, are over here on the left, H3O positive, and hydroxide ions are over on the left. So acids on the left, bases on the right. If acids and bases form a compound with ionic bonds, this is called a salt. Okay, so potassium chloride is an example of a salt. We can see that over on the right-hand side, letter C on this diagram. Neutral substances like pure water have a balance of positive and negative charges, so water will always have an equal number of hydronium and hydroxide ion. Another word for that is equilibrium, and we'll talk about equilibrium quite a bit later on in the semester. But on the left-hand side on this diagram here, we have an acid, hydrochloric acid, HCl, okay? And then we have a base in the middle. And that is potassium hydroxide. That is a form of a base, okay? Because here we have an acid, we have our hydronium ion, H3O plus, forming with chloride. And then over here we have potassium, which is positively charged, but then that's combining with a negatively charged